Welcome back. In this clip we will cache out our Whitewater, but first let's take one more look at the performance of our simulation. I already simulated 10 frames here to see where it lacks performance. As already mentioned, the most time consuming element at the moment is the guided ocean layer fluid and the Whitewater source. So we will cache out our Whitewater source. But also in our sim here the SOP solver is pretty time consuming, as you can see here. So we will do one more adjustment to our SOP solver to gain more speed. So let's jump in here, and you can see the particle fluid surface node here is the one which is really slow. So we can stop here the recording and let's switch back to the parameters. And what we will do now here is to lower the influence scale to 2. This will speed up the meshing process because it will take less points into account when meshing a surface. Okay, that's good. Let's jump back up, and now we will take care of our Whitewater source. So to get rid of the colors here, just re-record one more profile and stop it again. So now the colors are gone. And jump back up, and let's see here in our Whitewater source. So loading back in the high-res flip and calculating the Whitewater source takes quite some time. So we will use this cache node, which is already here, to cache it out to disk. And then we will use a file node to read it back in. So let's make sure the file path here is fine. $hip_geo, let's put $hip name, one more slash, that is a separate folder, $os, again a separate folder just to keep it clean. And then we will write out with $f, so every frame will be written out in a separate file. That's fine. 1 to 240 also working. So you can hit the save to disk button and let's wait until it's done. Okay, now it's cached out. So let's drop down a file node here to read back in our Whitewater source. Here is 0409 start, Whitewater source cache, and now make sure show sequence as one entry is ticked on, select your source, hit accept, and now here is our Whitewater source with all the attributes. Let's connect it to our cache node here, and now if we display this one here, you can already see it's much faster than loading in the whole flip simulation and generating this Whitewater source points. Okay, pretty nice. Let's jump back up and see how many particles we will emit. So back in our Whitewater simulation here, I already prepared a little note here so we have some values to work with. As said, with 10,000 emission I had the best result. It took about 2 hours and consumed 60 GB of memory while simulating. But for sure we can also use lower values, then we just have to adjust the rendering a bit, which we will also do. So if you use 5000 for example, you have about 50 minutes and 32 GB, or you can go even lower with 2000 or 2500, you're about 25 minutes, half an hour, and it took maximum 16 GB. So if you have a machine with 16 GB with 2000, you should be fine. If you have less than 16 GB, you can try values like 1000, but perhaps it will cause some problems when rendering it because we haven't enough points. So if you have more than 60 GB or 64 exactly, I would recommend using 10,000 as an emission value here just to get the maximum detail. So in this case, let's adjust here our Whitewater emitter. At the moment it's 100. Let's put 10,000 here, and now before caching it out, we shouldn't forget to reset the start frame of our simulation to 1. Otherwise it will run to 100 without writing out any frame. So let's put it here to back to 1, the start frame on our Whitewater sim, and we will again use the simulation take here to deactivate on our Whitewater object the allow caching. Otherwise it will consume even more memory because it's holding the whole previous frames always in the cache, in the memory cache. So make sure include in take here when you're on the simulation take, disable the allow caching on our Whitewater object, but do not disable it here on the cache simulation because the collision geometry needs to be cached properly. And also what we're going to do inside here, the Whitewater source, we're going to disable these cache nodes here for this take as well, because otherwise these cache nodes would fill the memory with the previous frames of this Whitewater source, which is also not necessary. It's just for iterating fast in the viewport. So right click here, flex, make bypass editable in take, boop, okay, and hit the bypass flag here, the yellow one on the left. And also we're going to the same thing with this here, actions, make bypass editable in take, and bypass it. Okay, so now if we switch back to our main tags, you can see they're still activated, but on our sim tag they are disabled. That's exactly what we want. Okay, so where do we cache our Whitewater out? It's here in the Whitewater import. So again, we won't cache out the already rasterized particles. I mean, we would save a lot of disk space, but we need to experiment with the values here on the volume rasterizer, the density scale, particle scale, and so on to get the best results. So let's move it down here and drop down a ROP output driver to cache out just the points. Let's call this Whitewater. And make sure again that we write two good paths. So $hip name, that's fine. $os and again a slash. So we have some subfolders to keep it clean. One more thing here, if you have a fast hard disk on SSD or RAID for example, I would recommend perhaps not using $hip, just picking your own paths to write the cache to the fastest disk you have, and perhaps not to a file server because the files will get pretty huge. With 10,000 emissions, the cache files were about 1 to 2 GB per frame at the most intensive point of the simulation. So make sure you have enough disk space and put it on the fastest disk so we can read it back in with a proper speed later on. Okay, that's fine. So don't forget to render with take simulation here and not the current frame. We will render a frame range 1 to 240. That's fine. And again here I would recommend to use the save to disk in background option, so the H batch will fire up, you get the scheduler, you can see the simulation time, and you can also monitor your memory consumption properly. Okay, we are ready to cache it out here. Just make sure to save your scene, then you can use the save to disk in background option. In the next clip we will start creating the mist, so we have all the layers together to get into the rendering. See you there.